All right, Math 136 students, this is a video on how to write solutions to inequalities in interval notation. The first thing to realize is that this is not the only way you can write your solution, but it is one that we use a lot in Math 136 and other classes moving forward. So indicating the solution to an inequality, such as x is greater than or equal to 4, can be achieved in several ways. Now, this is what we call just writing it as an inequality solution, but we could use a number line to show our answer. So notice that because this is x is greater than or equal to 4, we include a closed circle on 4, which indicates that the number is being used in our solution set. And then we're shading to the right because it is greater than, and the numbers that are greater than 4 are to the right. Now, in our class, we sometimes substitute this closed circle idea with what's called a bracket. So we've learned that closed circle is what a lot of times you learned in a previous math class will be equivalent to what is called a bracket, and open circle, which means the point that you started at was not included in the solution set, is going to be a parentheses, and that will be useful in a minute when we talk about the interval notation. Another way of writing a solution set to an inequality is called set builder notation. We don't focus on that one that much, but it's good to have an awareness that is a different way to write the answer. And essentially, you just take your solution or condition for membership in the solution set, which was x is greater than or equal to 4, and you put it in the set braces. So this is the set. This is actually how these symbols would read as a sentence. So the brace says the set of all x's. The straight bar there means such that, and then it is x is greater than or equal to 4. So that's the condition to belong to the answer. And that is indicating that it is in set builder notation. The third method, and the one we want to focus on in this video that we're going to ask you to do all of your solutions when we solve inequalities in our course, is using interval notation. Now, this is when the solution set is indicated with parentheses or brackets, indicating, remember, open or closed. In other words, is the endpoint included or not? And so greater than or equal to 4, x is greater than or equal to 4 can be represented as 4 with a bracket. Notice that helps if you've got the graph there. And then we shade everything to the right of that. So that's to positive infinity. And infinities will always be a parentheses because it's a concept, not so much an actual number. So we're not actually stopping there. So it's open-ended. I will tell you that the biggest thing we see students mess up on is they don't always put their interval notation in order from least to greatest. It should read from the number line from the farthest left that you shaded to the farthest right that you shade. So it only needs to be in least to greatest order. And this is going to help us do a lot of other things throughout the course. So these are just some examples of how a sentence would be read, how it looked as an inequality, and how that would look in interval notation. So notice when an x is between two endpoints, we don't have an infinity at all because we are shading in between a and b. A is the smaller one since this says a is less than x and x is less than b. So this says that I've shaded, or all of my solution sets fit between a and b without including the endpoints because there is no equal to. X is greater than a would be a with a parenthesis since there's no equal to, and we're shading to the right. X is less than b means that we actually have b not on the right, the left side, but on the right side. This is saying we're shading everything from negative infinity up to b. So notice again, least to greatest. X is greater than or equal to a and x is less than or equal to b. That just changes it to a bracket on both of those. This one has what we call half open, half closed. So this has equal to on the A, and this one has equal to on the B. So make sure you realize that the equal to goes with the piece closest to it. This one has both of them being closed on the ends. And then this is two, and by the way, these are called and statements. When you have the string like this, it means that both of these conditions have to be true at the same time. If you split it up into two separate inequalities, this would say x is greater than or equal to a and x is less than or equal to b. Those are shading in opposite directions, and the solution set, when you do an and problem, is what they overlap at, what they have in common. Now, an OR set means that we're just stringing together two separate answer solutions that may or may not intersect, and we string them together what's called a union symbol. We use this a lot when we're solving inequalities that have polynomials or rationals in them because you will get solution sets that are kind of chopped up throughout the number line. And then sometimes the whole entire number line is shaded, and that would be represented as negative infinity to infinity. So the only thing we really want to do in this video is just practice going between the two formats. So we're going to take some inequalities and we're going to write them in interval notation. And I put sketch a graph because sometimes it's helpful when you're first starting these to sketch the graph first, and then you can write your interval notation from that just to get used to it. And then in the second group, we're going to be taking the interval notation and rewriting it as an inequality solution. So for this very first one, it says x is less than or equal to -2. So when we want to write that one, let's just draw the graph first. So this would look like this. We have, and I don't care if you put a ton of numbers on the number line, we're just trying to get a reference. Here's -2. It's less than or equal to, so that's a bracket, and less than means we're shading to the left of our number. So in interval notation, we read that from left to right. So that would be -infinity, because that's the infinity to the far left, up to -2 with a bracket. X is greater than 1. We start at 1, and it's a parentheses since there's no bracket. No equal to, sorry. So there's a parentheses there. We shade to the right that's greater than. So that from left to right reads as 1 to positive infinity. And notice my infinities are always getting parentheses no matter what. So these are the ones where x is in between. So we have, and I'm going to put more numbers on this number line since we have in between. So this is -4, -3, -2, -1, 0, 1, 2, 3. So we have a bracket on -4 because the equal to is next to that one. And we have a parentheses on 3 because that has no equal to. And then x is somewhere in the middle. So we shade everything in the middle. In interval notation, we still read that from left to right. So that'd be -4 to 3 with -4 getting a bracket and 3 getting a parentheses. Now D, I tried to trick you up a little bit. Notice these were always less than, less than. That means it was going already in order from least to greatest. This is backwards. This is greater than, which means we want to fix it first before we graph it. So you can flip the whole inequality around as long as you're careful of two things. First of all, make sure you flip the numbers, and then you want to flip these two inequalities, not only their positions, but their direction. So this was pointing to -3 and it did not have an equal sign. So we want to make sure it's still pointing to -3 and did not have an equal sign. This one was open to the -1, which means like its opening is there and the x is getting the point, and it has the equal to. So we want to make sure that is also consistent. To graph this one, you would do -3 with a parentheses, and -1 with a bracket, and we're shading in between. So in interval notation, that would be -3 to -1 with the bracket. It is important that your interval notation is order from least to greatest. Okay, so these are the opposite direction. We're going to take the interval and we're going to write it back as an inequality. So here's a quick way to kind of figure out which way this is going to go. You've got the bracket and the parentheses to tell you if there's going to be equal to or not. And if there are two numbers, you know that x is in between. If you have an infinity, you know you're going to be either a greater than or less than, depending on which way it goes, and it's going to be a singular statement. So this would be -2x3, because it's in order from least to greatest. This is going to be less than or equal to, and this is just going to be less than. You should never have two inequalities opening up to the middle or pointing both to the middle. It should always be in a string where they're headed in the same direction, because this is in order from least to greatest. And then this would be 0, x, 5, and they're both parentheses, so they're both going to be less thans. Now this is -2 to positive infinity, so that's bigger than -2. So that would be x is greater than -2, no equal to sign. And this is shading to negative infinity, so that would be x is less than or equal to +3. All right, I hope you guys enjoyed this short video. This is just in case you needed to brush up on interval notation, and there will be more videos to come.